So hey everyone, welcome back. Again, we are going to see the error as we have already discussed the basics of error, and we have almost discussed everything which is related to error. We are going to see some examples, and we are also going to see some uh, error like percentage of error calculation, like when the term is given in the terms of powers, term of power, so how we can calculate it. So we will discuss all these things in this video, and then we'll also talk about dimensions. So yeah, so first let's discuss about the, like suppose we have given, z is equal to a square. So then what is the relative error in this, like z quantity? So it would be like delta z upon z. So here it is like 2 delta a upon a. So now you gonna amaze that how it came. So basically there is a differential. If you don't know about differential calculus, and differential calculus, uh, that you should know in your maths class, but I'm just gonna give you some basic overview here. So, like suppose we have a x raised to n, y is equal to x raised to n, then the differentiation like dy by dx we can also write it. Or if it is in very small, and this can be most equal to delta y upon delta x if the quantity is greater. So then I am just writing it like n x raised to n minus 1. This is the formula. This is the formula which we use here. So that's why we can say here dz upon z is equal to, like similarly here we can write dz is equal to 2 dA. Now if we divide by here z, here it would be a. So this d will become, how will be, delta z upon z is equal to 2 delta a upon a. So like this way you can do. Now suppose we have y is equal to a square b power minus 3 g c cube c power, uh, suppose suppose 3. So how it would be, delta y upon y is equal to 2 delta a upon a. Here it is minus, but if we are taking it in terms of uh, error, then we will take it negative, not negative, we will take it positive, 2 delta b upon b plus 3 delta c upon c. So this would be the error. Now we will come to know about the error in A, error in B, error in C. Now we will just, if we want to get percentage, multiply by 100, multiply by 100. In every quantity, you just multiply by 100, you will get the result. So now you understood how we can, like get the percentage error in if that quantity is given in terms of powers. Okay, and we have also seen this example. I'm gonna I'm going to tell you another example. Like suppose we have a z, which is, now this you have to do, a raised to 4, b raised to 1 by 3, c raised to uh, c d raised to 3 by 2. Now what going to be happen? Delta z by z is equal to 4 delta a upon a plus 1 by 3 delta b by b plus delta c upon c, because there is no any quantity, plus 3 by 2 delta d by d. So this is the way you can solve it. So now we have almost discussed about the error. Now let's move on to the dimensions. Okay, so this is your dimension class, and dimension analysis. Dimensional analysis. You go to see what is dimensions and what is the dimensional analysis basically. So what is dimension? Suppose dimensions are basically the power which you write in any quantity, in any, like on any physical quantity, I would say, because we have total seven physical quantity, or we can say these are the fundamental quantities. So dimensions, fundamental quantity. There are total seven fundamental quantity. So the dimensions are the power on these fundamental quantity. We can say the dimensions are like it can be 1 by 3, 2 by 3, anything, but it is number. It is not like anything which you see M, L, T in form of these, but these are the power, suppose 3. So here the power of M, that is M is represented as mass, L is length, T is temperature, time. So here the dimensions of these quantities are 1 to 3. Suppose if I would say, someone said that the dimensions of mass is equal to 1 by 3, dimensions of length is equal to 1 by 4, dimensions of time is equal to 2. Then find its the dimensional formula. Then you just need to write like this way, and it would be its dimensional formula. So dimensional formula is different than dimensions. Dimension are just these power. Dimensional formula, when we combine these power with the physical or fundamental quantity, then that becomes the dimensional formula. Like suppose we have a force. Force is a physical. Force is a quantity. You can say quantity. Force is a vector quantity, but I'm just taking it as a quantity. So you know force formula is equal to mass into acceleration, where mass is having capital M, acceleration is again divided into velocity upon time, v upon t. Now velocity again having mass into velocity is length upon time, and time, one time was already there, so this. So now m l upon t into t square. So now if it goes above, it would be like m l and t raised to minus 2. Now this becomes the dimensional formula of what? Force. Why? Because now we have see the power of m is 1, power of l is 1, t is minus 2. Now if someone says what is the dimension of uh, m in force, dimensional formula, that is 1. What is the dimension of l? That is also 1. What is the dimension of t? That is minus 2. And if someone said that these are the dimension, write the dimension formula, you just have to do that. There is no any things which you have to be. You have to just know these things, and then you can write with the help of this signs. You can, with the help of these signs, you can write the dimensional formula. So this is all about dimensions. You can, for finding the dimensions, you have to know the formula first. Like if we talk about energy, we have so many dimensional formula. I can just tell you, like suppose we start from the length. So length is having dimensional formula L raised to 1. Then we have I'm just writing the first seven fundamental quantities. Mass is having capital M. Time is having capital T, and temperature temperature is having theta. You can write theta, and electricity is having I. You can write this I, and then we have Kelvin. Temperature we can write like this way, and then we can also write like luminous intensity, that is bleeding. You can write I think there is L or something, you can find it in the textbook. And for small n is for the mole. So, but the mostly you will find that is related to LMT. Very rare you will find theta, like temperature, and there are very few, like one or two there, in which you will find this one also. Current is also. So now we we are going to see basic, few basic, like first we will start with the velocity. Velocity, then we will move on to the acceleration, then we will move on to the force, then we will move on to the energy, then we have power, then we have momentum, then we have then inertia. There are different quantity which you can write. There are so many quantities, like these are the derived quantity. There are seven fundamental quantities, and these are the derived quantity. Now you know derived quantity are those quantities which have been derived from these fundamental quantity. If I will talk about velocity, velocity is equal to length upon time. So velocity is derived from length and time in a given interval. The distance travel by the anything that is related to velocity, that is also a derived quantity. Okay, now you know what is the I would say scalar quantity and what is the vector quantity. There is nothing to like go in these things because they are simple. If you don't know, there is having only magnitude, and there is having magnitude and direction both. And you can find so many quantities which are like scalar and vector, and few quantity which are seems to be scale vector but they are not. That you have to keep in mind. One is that electricity, that is current. Okay. Now we have understood the dimensions as well, and let's check the textbook. Your textbook. What is it saying? Dimension analysis. Okay, it's application. Now we are going to see the applications of the dimensional analysis. First, basically checking the like suppose we have given any equations, then we will verify through the dimensions, verify whether equation, first thing verify whether equation is correct or incorrect through the dimensional analysis, or incorrect through the dimensional analysis. How? Because if the dimensions are not correct, like from left hand side and right hand side dimensions are not equal, it means there is the formula it might have wrong. But if it is equal, then it would be correct one. So that's you can verify the like mm, the equations or the solutions, and we can also find derive the relation. We can also derive the derive the relation between quantities. Okay, derive the relation between quantities. Okay, through dimensional analysis you can do it. We will also like do all these things. Okay, so let's just check how we can derive, how we can like check whether the equations is having correct or not, and then we will also derive some relationship through the help of dimensional analysis. So first let's check this one. uh, this first thing, derive whether equation is correct or not, verify whether. So we are going to see, right? We have suppose x is equal to x naught plus v naught t plus 1 by 2 into a t square. Okay, so now we can say we want to find the dimensional formula of these things. Okay, so I have already told you that having having same dimensions can be added or subtracted. If I haven't, but I am telling you right now, I will tell if you can write it as a note. And there is, if suppose we have a different direct dimensions, we can not add or subtract them, but we can multiply them. We can multiply or divide quantity, even if they are having different dimensions. So there is not that is going to be going to be problematic if their dimensions are different, if they are multiplying or dividing. So, but in case of addition and subtractions, we cannot do it. Like length can be added with the length only. Length cannot be added with the time. So you need to understand it. You need to know it. Okay. So then we have the first thing that I have told you, that the dimensions from the left hand side is equal to the dimensions on the right hand side. So the dimension of x, which is length, is equal to the dimensions of x naught. Now you can find the dimensions of x naught, which is okay. Now the dimensions of x naught, that will be equal to the dimensions of v naught t. The dimensions of L is equal to v naught t. The dimensions of v naught is equal to L, t is time, so L t. The dimensions of v naught is equal to L t inverse. So this will be the dimensions of v naught. Now similarly, we have dimensions of this one is equal to dimensions of this one is equal to dimensions of this one is equal to dimension of this one. So we can say half at square is equal to L, because that is also a length. Now this 1 by 2 is no use. Why? Because it is a integer. That integer are dimensionless. Now a is equal to L upon t square. Now a dimensions of a would be equal to L t minus 2. Now you can find the through the dimensional analysis, you can find the dimensions of different quantity that is used in an equation. So like this way you can do any other questions. I have done one simple question for you, but if you want to do, you can do any other as well. So let's go to the next one, that is to derive the relation between the quantity. So suppose someone says that I am just going to give you an example through which we can solve this question. We can, like, we have a simple pendulum. We have a the first thing that we have a simple pendulum. Okay, simple pendulum. You know, simple pendulum. I'm just giving you an example. This is the simple pendulum, and it is just hang over this way, hanged like this way. Now it can go like this way, zigzag motion or to and fro motion from the center. And if someone said that its time period depend on its length of this rope. Time is depend on length, and its time period also depend on g. Okay, then then find the relation between the uh, derive the relation of this. So how we can do it? So for that, we say that it's depend on length power n, its time period depend on g power, or we can write it here a b c, not n, whatever you just you can. It's up to your choice. We are just writing a b, so we can write it combining both. T is directly proportional to length power a, g power b, And to remove this proportionality constant, we need to add some proportionality constant. Let's say L raised to A, G raised to B. Now what we can do, there is a dimensional analysis. I have already told that the dimensions of left hand side is equal to the dimensions of right hand side. Okay. So by using this method, we can say that dimensions of T is equal to dimensions of L raised to A. G is having LT minus 2 raised to B. L raised to A, T raised to B. Okay, so dimensions of T is equal to L raised to A, L raised to B, T raised to minus 2B. Okay, so now here A and B that both will be combined. So dimensions of T that will be equal to L raised to A plus B, and then dimension minus 2B. Now we can use the uh, equality method, that if T dimensions of T L raised to A plus B and T raised to minus 2B. Okay, so here then A plus B equal to 0, because there is no term L raised to 0. We can write it like this way: A plus B equal to 0, and minus 2B is equal to 1. So B is equal to minus 1 by 2. We got that. And A is equal to minus B. A equal to minus B. So A will be equal to 1 by 2. Now we have got that relationship of the power like A and B values. Now we can write that P is equal to K. We have already written is like L raised to A. So L raised to B raised to like G raised to minus 1 by 2. So T is equal to K, or root L power 1 by 2 root upon G. Now K is 2 pi. That you will find through the, but that is not going to be useful. But the thing is that we have derived equations, that is important. So yeah, through this way we can also we can derive the equation as well. So the use of dimensional analysis, you can say, is a huge. First we can we can check the equation whether it is correct or not. We can also find the constant which are there inside the equation by using the equality method of the dimensional analysis. Then we can also derive the equations by using the dimensional analysis. Okay, suppose if I say there is some term which is having some plus, then can you find it, the relation? Because we have here that we already thought, or we already taking the assumption that they are in the multiplication. But suppose they would be like this way, whether we able to, I don't think we can do, because they cannot be uh, added here, because they are having different dimensions. So that's why if they are in multiplication and we assume that they are in multiplication, then we derive the equations. So this is all about your dimensional analysis, unit and measurement, and I guess you have your doubts whatever it will be till now, it would be cleared from here onward. And if you have any sort of doubt related to any concept, if you do not understand, you can reach out to me, you can comment me, and let's go on and do some basic questions which are coming into your textbook, which are there inside your textbook. If you want, I will definitely try to solve all those questions, but because we don't have much time, and if we cover all the questions, it will take so much time to cover those things, and the time will be so much long that you cannot do. Okay, so till here we can concise out the discussion, and in next part we will do some questions, and then it will be like your measurement and like unit and measurement chapter will be completed, and it is completed, but there is some questions which will be discussed as well, that is related to your exams, and that would be for your concept clearance. So thank you so much. If you enjoyed this video, please have us like and share this as well. Yeah, bye.